And we're back. Excellent. I don't know. I don't have anything witty to say other than we're back. I don't know. I'm sure it's so funny thinking about like the fact that all you guys have been virtual all week and stuff like that, but I'm just imagining like first period for what it's like for a high school student to just barely be waking up and like, all right, let me go learn some advanced placement statistics or some junk like that. I don't know. But we'll figure that out. I'll give people a minute or so to kind of get in. Because I see there's 14. I'm waiting for that number to grow a bit higher than that, 14. Just some basic announcements, kind of regardless of today. Next week, I have you on Wednesday, Friday. Just as a reminder, you have Monday off. I have you on Wednesday, Friday, in which we will be reviewing for our midterm. Our midterm during the week of the 25th, the 26th, 27th, 28th, that whole thing. The assumption is that you will be back in the classroom, but I've been reading a lot of articles about just, there's a surge coming to New Jersey. Oh, that sounds great. That sounds nice and, pleasant. No, that's where we're at, My kid is supposedly going back to school next week. I don't know. He's going back on Tuesday, the 19th. He goes to school in LBI. And, they're moving forward with that plan. Now, mind you, it's a bit different in that particular elementary school. In that particular elementary school, there are barely 10 kids in his class. They don't change classes in the hallway. They have had a lot of restrictions put into place in terms of keeping kids safe. So, I'm actually pretty content with my son going back to school. Not so content with, 20 kids being in my classroom and wandering from class to class. But, we'll figure that junk out. If you haven't already done so, of course, leave a comment in the chat. That'd be great for my records. Sorry, it's just everyone's like here, and then I say good morning, and then I say woo. It's just, oh goodness gracious. Anyway, so what are we doing today? Today, I would like to continue with what we've been doing with binomial and geometric probability distributions. I have a ton of word problems that I would like to throw at you. But these word problems are going to be in the form of a quizzes. Now, the intention of this quizzes is a practice first and foremost, but it will not take the whole class period. My intention after the quizzes is to review those questions with you. Now, I am going to be throwing an assessment at you in regards to the last couple of chapters before I leave the building here today. The only intention for next week, of course, is to review for midterms. But I want to wrap up this whole probability thing. So number one, practice quizzes today. We're going to review that stuff today. Before I leave the building here today, I'm going to be throwing an assessment at you on Google Classroom. You'll see that. I just need to dot a few T's and cross a few I's when I get there. And then I will be I will be assigning that to you. And then I won't see you till Wednesday. Well, I won't see you. Shut up. Anyway, so that's the goal. So what you will need for said quizzes, obviously you will need some form of graphing calculator. Obviously, most of you will be using what is directly on your Chromebook, which is fantastic because you will need that for certain problems on this practice quizzes. I would strongly suggest that you do have your notes out as a reference. Again, the intention of this quiz is not to take forever. It's to see, okay, what do we recognize? What do we know? What do we not know? What do we need help with? That kind of thing. I am going to be turning on the quizzes, the redemption questions. I will be turning those off because, again, I want to get it's a practice, but I want to get an honest feel for what you know and what you don't know. And I want you to think about what you're clicking. Again, just a practice. So let me bring this thing up here. Close that. Flip that over. Duplicate. Start dat. Classic. Let me turn off redemption questions. I'll leave the memes on just for funsies. I don't know why I would, but boom. Now, of course, none of y'all can see the code because there's a giant glare in the way. Funds, So I am going to be typing said code into the chat. And I will be writing said code on the board 774315, just so I can throw that into the chat. And I would like you guys to start joining this thing. 774315. Again, just being a practice one. I don't want you to spend all of your time on a single question. That would make me sad if you spent all of your time on a single question. But like I said, this is just data gathering for me. I'm assuming, because I see 19, now 18 people in the chat. That's weird. I'm going to assume that there are a few people missing. Perhaps they will show up in the next few minutes. If they do, I will leave a comment in the chat in regards to how they can still join as long as this thing is still live. But once I click the end button or whatever, then the whole thing will be done. So, yeah, I only got 7 in. Join my quizzes. Join my quizzes. Let's see what we got here. We got 10 so far. I'll give it a few moments. My wife and I are trying to catch up on TV shows that we watch. We just finally started season 3 of Cobra Kai. Amazing. And then WandaVision got released on Disney Plus this morning. We haven't watched that yet, obviously, but we will. The code isn't working. What? The code isn't working. Hold on. 774315. 74415. Try not closing the chat, but try just opening up a new, close out the quizzes and open up a new Chrome thing and see if that works. Because sometimes people who close it out and open it back up, it tends to reset itself. It's the old IT crowd mentality. Have you tried turning it off and on again?
Good morning, Excuse Interruption teachers. I did share out a quick 3-question survey. If you have a moment, please jump in and fill that out this morning. Thank you.
They want me to fill out a quick 3-question survey. How about no? Anyway. Dylan, if that code doesn't, obviously, oh, never mind. Look, there he is. I spoke too soon. But yeah, there's, 19 people in the chat and only 14 people who have joined. Again, I'm going to click start in a moment so you all can get started. If you have not joined yet, please, by all means, do so. You can still join even after the thing has begun. But I'm going to click start. Again, binomial, geometric problems. Use your notes. We're going to review the most difficult problems after the fact. Let's see how this goes. Woo! Get hyped. And click. Again, if you haven't joined, make sure you join. Oh, there are more. I see more people popping on. I'll have to turn down that volume. I'm going to give you guys another 2 minutes to wrap this up, and then I want to start reviewing some questions. See, I want to end it, but I want to see if he can do it. I'm looking at the leaderboard. I think I'm just going to give him until he answers his question. All right. I'm gonna click it. Click, click, click. There we go. Okay. So I'm going to take a look at some of these questions because there's some questions that I know I definitely would like to review with you guys first and foremost. So obviously you should already have them out, but if you don't, I'm going to need those notebooks out and open. These quizzes can be a very easy way to collect the data that I need. I'm going to make a note for myself. Questions 4, 5, 12, 13, 15. Now, obviously, you had them in a random order. But mine are not normalized. Let's start with question 4. What I'm going to do is this. I'm going to write down the information that I need to answer the question, and then I'm going to flip to the top-down Elmo so that you can see exactly what I'm writing. So it says in number 4, Peyton Manning completes 67% of his passes. Oh, by the way, just for the sake of argument, I'm going to call this Binom Geomet Quizzes Review. That's what I'm going to title it in my notes. And today is the 15th, I think it is. Yeah, I think it is. So Peyton Manning completes 67% of his passes. What is the probability that it takes fewer? What am I even reading today? What is the probability that it takes 4 throws to complete first pass? First pass. Oh, my word. I can't even talk today. Complete first pass. What a terrible handwriting I have. Can't even speak proper English. Chapow. Okay. That's what I wrote down in my terrible handwriting and messing up several times because, I don't know. Peyton Manning has a 67% accuracy or completion rate, meaning the probability of success is 0.67, 67%. They want to know what is the probability that it takes 4 throws to complete the first pass. Now, according to our quizzes, it looks like, only 5 got it right, 13 got it wrong. There are 2 ways that you could answer this particular question. 2 main ways. One way is, okay, he's going to complete it on his 4th attempt, meaning he's not going to complete it the first 3 attempts. So you could do 0.33 times 0.33 times 0.33 times 0.67. That's one way of doing the problem, because it would be under the assumption that he would miss the first 3 and then finally hit that 4th pass. If you were to calculate that very carefully, that should give you approximately 0.024, which it does. But the other way of thinking about this particular problem, the other way of thinking about it is thinking of it as a geometric distribution. Because, well, you're looking to get that first success. It's not, let me repeat, it is not that you are looking to get 1 completed pass in 4 attempts. It's that very specifically, you are trying to get that first completed pass on the 4th attempt. It's a first success problem. It's a geometric problem. More specifically, it is a Geomet PDF. It is a Geomet PDF. Now, I'm going to go to my calculator here. So I have the same interface as you. If you didn't have this interface, typically they ask for the probability of success followed by the trial that you got that success on. Second, vars, Geomet PDF, 0.67, 4th pass or attempted pass, There it is. The exact answer that I got before, which, by the way, you can see right there, it's the exact same decimal. 0.024, regardless. So I would put in 0.67 comma 4. There we go. Flip. No. Flip. There we go. That's what I wrote down. The hardest part about all these problems is understanding what the question is asking. What type of question is it? Which function do I use? What numbers do I plug in? It really depends. Let's take a look at, by the way, there it is. Peyton Manning. Why is the answer 0.01? Oh, I know what I did wrong. I completely misread the question. That is how distracted I am today. Okay. It's a good learning experience. Everything that I wrote down, including this question, everything here is technically correct if that's the question I was trying to answer. I'm not going to erase any of that. I am not going to erase any of that. This question that I have written down in my notes is getting your first complete pass on the 4th attempt. But I completely just skimmed that question. I skimmed that question like someone who doesn't know how to read math problems. Goodness gracious. So now I got to get a new question in my notes. Goodness. Like I said, I'm not erasing any of that, but I know that I answered the wrong question. Peyton Manning completes 67% of his passes. What is the probability that it takes more than 4 throws to complete his first pass in the game? Ooh, more than 4 throws. That is a completely different question. It is still a geometric problem. But now we're dealing with a CDF problem. So, because here's the thing. Analogy. Not analogy, just visual. Which pass does he get the completion on? Or which attempt? The question is basically saying, okay, more than 4 throws. Meaning we want to know everything going in that direction. We want to know the probability that it will take more than 4 throws, not including 4 throws, but more than 4 throws in order to get that first completion. It's still a geometric problem. It's a geometric CDF problem because it is a cumulative problem. It's a cumulative function. But when you use Geomet CDF in the calculator, it calculates getting that first success on a certain trial or sooner. So what I'm going to have to calculate is this. First, I'm going to calculate that. And what that will do is it will calculate the probability of getting the first completed pass on the 4th attempt or less, meaning the 4th attempt or the 3rd or the 2nd or the 1st. And in order to answer this question correctly, I got to take the complement. That is the proper way to do this problem. And if it's not, then I quit. Let's see. Geomet CDF 0.67 4. That'll get me that crazy number. But again, in order to answer the question of more than 4 passes, meaning 5 or more, I got to do 1 minus that answer. to get to 0.0118. I'm going to round that to 0.012. That's what it really rounds to. Yay, I did it. It's very easy if you, like I did just a few moments ago, it's very easy to skim a problem, think you understand it, and go in a completely weird direction. And then when your answer doesn't match any of the choices, you're like, oh, crap, let me just guess. We need to learn from those mistakes. So I'm actually going to read the question next time. Let's take a look at number 5. Number 5 is, again, one of those problems that most people got wrong. A set of 20 cards consists of 10 purple and 10 green. Okay? If you pick 7 cards at random without replacement, what is the probability that you will get 3 purple cards out of the 7? Ooh. Very interesting. And then they want to know whether or not it was binomial or geometric or neither. Well, without replacement. Meaning you're putting the cards back in. Or I'm sorry, you're not putting the cards back in. Now keep in mind there are 20 cards and you're picking 7 of them. You're picking way more than 10%. It does not seem to me like these events are independent of each other. It violates the 10% rule. Boop. Yay, I did it. I didn't have to write anything down. Cool. All right. But that's honestly the reason for that. You can't model number 5 as a geometric or a binomial, because each trial, you cannot assume that each trial is independent from the next. And the reason is, well, yes, it's without replacement. I understand that. But the 10% condition could cover that, but it doesn't. There are 20 cards. And if you were going to do this without replacement, at most, you can only pick like 2. Scrolling down. Number 12. The American Red Cross says that about 11% of the population have type B blood. A blood drive is being held at your school. How many blood donors should the American Red Cross expect to collect until it gets a donor with type B blood? Now, this is, again, one of those questions that I can noodle out without having to write much down. They never actually said it, but they're waiting to get a first success. As a result, this problem is a geometric problem. It's a geometric problem. Now, I don't actually have to use Geomet in the calculator, but this is still a geometric described problem, because they're trying to figure out how many should they expect to collect until it gets a donor with type B blood. How many people will we have to go through until we get that first success of type B blood? Well, according to your notes, the expected value of a geometric is 1 divided by P. P being the probability of success. Nine and change. Let me look at the choices. No, 9.1. Yay, we did it. Oh, look at that. More than half of you chose cannot be determined. That's interesting. Well, the assumption is that each person is independent of the next in terms of the type of blood they have. You have a probability of success, and you're trying to figure out how many you would expect to go through until you get that first success. Yep. Number 13. Ooh, I love it. I'm going to write this one down. The American Red Cross says that about 11% of the U.S. population type B blood. Yes. A blood drive is being held at your school. Yes. What is the probability that at least 2. What is the probability that at least 2 of the first 10 have type B blood? Now, I'm going to draw something or write something out, and then I'm going to have you look at it. There it is. If you have 10 people, there is a chance of getting 0 people all the way up to 10 people with type B blood. And they want to know, what is the probability that you have at least 2? The probability of at least 2. At least 2, meaning 2 or more. 2 or more. They want to know that. They want to know 2 or more, meaning 2 all the way up through 10. This is a binomial CDF problem. It is binomial because you're looking to get at least 2 successes or more out of a finite number of trials, 10. A certain number of successes out of a finite number of trials. This is a binomial. It's CDF because you're doing more than one of these events. But the problem with the CDF in the calculator is it only calculates or less. It doesn't calculate or more. So the sneaky thing that you're going to have to do is this. You're going to calculate binom CDF, 10 trials, 11% chance of success with a 1. Because by calculating it like that, that will calculate 1 or less, meaning you would get the chances, or that combined probability would be the chance of getting 0 or 1. And then you would simply have to take the complement in order to get the rest. Let's take a look. Binom CDF, 10 trials, 11% chance, 1 or less. You got that. But as we said, we need the complement. Looks like 0.303. Let me take a look at the choices. Yep. A lot of people chose 0.214. I wonder why. 0.214. Let's take a look at another one. Let's take a look at number 15. Heck yeah. The owner, pet store, is trying to decide whether to discontinue selling specialty clothes for pets. As a side note, the answer is yes. She suspects that 4% of the customers buy specialty clothes for their pets. Sorry. What is the probability that she does not sell a garment until the 7th customer? It sounds like a geometric problem. They tell you in green to assume independence, so we're going to go with that assumption. 4%. Okay, so hold on. The probability of success is 4%, so 0.04. She wants to get that first success, or not that she wants to, but she's thinking about getting that first success on the 7th customer, exactly the 7th customer. Meaning, this sounds like a Geomet PDF with the following numbers written in 0.047. Let's take a look. Binomial or Geomet PDF 0.04 7. Looks like 0.031. Let me take a look at the choices. Yep, 0.0313. Technically, it rounds to. A lot of people chose 0.027. I like to know sometimes like why people chose certain answers. That's interesting. Let's take a look at a few more. Now, we went over all the red ones, but I want to talk about some of these yellow ones. But I don't want to do all of them. No, not that one. Ooh, yeah, let's start with... Yeah, let's do that one. Okay, we'll do this one, and then I'll kind of move on to the next one. I won't write anything down for this, but I want to do 6 and 7. The American Red Cross says that about 11% of type B blood, blah, 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 blah. What is the probability that exactly 2 of the first 20 donors have type B blood? And if you notice the 4 choices, they don't give you the probabilities. They really just want you to figure out, okay, how would the formula go? Well, first and foremost, this is a binomial problem. This is a binomial PDF problem. And I gave you a formula for binomials, which includes that NCR calculation, N being the number of trials, 20, R being the number of successes, exactly 2. It's got to be the first or the second one. Now, you're looking to get exactly 2 successes, and there's an 11% chance of success. It looks like the second option. The second one. Let me see here. Yep. I mean, most people got that right, but it was still in the yellow for some reason. Makes me sad. But yeah, that's what you would do. But in reality, I wanted to take a look at this one, number 7. I'll write something about this down. When rolling a fair die 100 times, what is the probability of getting a 4 exactly 25 of those times? Now, in reality, if you were rolling a die 100 times, you would expect about 16 or 17 for each result. That's what you would expect to happen. But now they're saying, well, what about 25? What are the chances that you would get 25? All right, let's take a look. I'm going to write some stuff down. N equals 100. P equals 1 over 6. X equals 25. Now, there we go. This is a binomial problem. You have a set finite number of trials, and you're trying to find a certain number of successes within those trials. And because you're getting exactly, let's say 24, 25. 25. That's a 5 right there. There we go. Because you're looking to get exactly that many successes, it's a PDF problem. That's the calculation that has to take place. Let's see. Binom, PDF, 100 trials, 1 out of 6, 25 successes. Ooh, that's incredibly low. 0.0098. Yeah, rounds up to 0.01. Nice. I can see 6 people chose 0.167 because maybe they just did 1 divided by 6. See, the interesting thing is, depending on the number of times that you roll it, the more times you roll it, the more likely the experimental probability would get closer and closer to 1 out of 6. It's really interesting because they're talking about 25% of those. 25% of those. That's really interesting. Sorry, I'm just thinking about how Yeah, 5 out of wow, yeah. That's interesting. Check this out. I'm gonna do a couple different calculations here real quick, just to kind of show you kind of one of the more fundamental things about statistics. Binom PDF 100, 1 divided by 6, 25 gives you this number as we just talked about. But now, all of a sudden, let's just say that I reduced the number of trials. I reduced the number of trials to give you this. Now, 5 successes out of 20 is the same probability. Or, I'm sorry, is the same proportion. I should specify, not probability, proportion. 25 out of 100 is the same as 5 out of 20. 25% successes. But the chances with 20 trials is much higher. And the reason being is because the lower the number of trials, the more variation that could happen. The more variation that could happen, the more likely you'll get one of these crazy outcomes. The more trials that you have, the less likely that you would deviate farther away from the expected mean. Oh, statistics. Okay. That's it for me today. I'm going to be assigning you something to get some more stuff done with probability. Pay attention to Google Classroom. Bell's going to ring about nowish. Yay. Anyway, I got to get to my next class. Auf Wiedersehen.